Hi everyone. Today we'll take a look at division into groups. Now, the most important thing to remember about division into groups is that it's done for distinct objects. Okay? So only and only if the question mentions that this is, we're dividing distinct objects, do we follow this method. For example, people, right? People are always distinct, right? People are always distinct. And those are the most of the examples we're going to be discussing. So, like, books are not distinct. Books are usually not distinct unless until, they explicitly mention that one book is of science, one book is of math, one is of history. In those cases, you can consider them to be distinct. Otherwise, they're not distinct. Clothes are not distinct unless until they're specified with specific brands. Okay, so we're gonna have two parts of groups, right? We're gonna have one of unequal sizes, and we're gonna have one of equal sizes. So let's take a look at unequal sizes. Okay, so in this example, we're told that we have to divide. How many ways can we divide 10 people into groups of 4 and 6? Let's say we're making a band. Maybe we're gonna have some string instruments where we need 4 people to play for string instruments, and we have percussion for 6, right? That's how we're going to do it. And we have total 10 people, 4 for string, 6 for percussion. How can we divide it? So the first way, or the best type of approach I can say, is to make a picture out of it, right? So let's say we have 10 people. I'm going to make a picture. And I have to divide into groups of 4 and groups of 6. Now, there are multiple ways of doing this, right? The easiest way is using what we learned in combinations, right? Let's say I have to make a group of 4, so we can do 10C4 because I really don't care in which order I pick them. I just care that I pick them, right? Because they're distinct people. And that remains, that creates 6 people remaining. So 6C6. It's like selecting a team, how we would pick, a team, we have 10 girls and 6 boys, and we have to choose a team, something like that. So we're left with 6C6. And if we simplify this, then, 6C6 is basically 1, so I can ignore it, and I'm left with 10 factorial by 4 factorial by 6 factorial. Now, if you take a look at the tree diagram or whatever picture that I've drawn here, it's almost like you have your 10 here, you have your 4 here, and you have your 6 here. It's kind of like that. That's what it is. So essentially, you can use this as a shortcut. Whenever you have unequal sizes, remember it's for unequal sizes only. The shortcut that if you have the 10 people and the number and the two sizes of groups are 4 and 6, you can just write it like that. So let's say you have uh, let's take another example. So for example, you have 10 groups now. Sorry, 10 people, 3 groups, one of 5, 3, and 2. So again, let me draw a diagram here. So I have 5, 3, 2. So the shortcut would essentially be, let me do it like this. The shortcut would be just to write 10 factorial by 5 factorial by 3 factorial by 2 factorial. And that's it. That's all. Now let me show you how we get it. So let's say we have 10C5, 3C2, 3C, sorry, not 3, 5C3. Because once we select these 5 people, we have 5 more remaining, and we have to make a group of 3. And then we have 2 remaining for 2. I mean, you can really do this in any order. You could do maybe 10C3 first if you want. You can do 10C3, then you can do maybe 7C2, and then 5C5. Both ways, you're gonna get the same answer. You're gonna get this part at the end of the day. So let's say 10 factorial by 5 factorial by 5 factorial times 5 factorial by 3 factorial by 2 factorial, and then 2 factorial by 2 factorial. So this is out with this, and that gives me 10 by 5 by 3 by 2. That's it. Now we have 10 factorial by 7 factorial by 3 factorial. Then you have 7 factorial by 5 factorial by 2 factorial. And then we have 5 factorial, which is just 5 factorial by 5 factorial, which just cancels out. So 7, 7 cancels out. And then again, I'm left with 10 factorial by 5 factorial by 3 factorial by 2 factorial. It's the same exact thing at the end of the day. So, these formulas are basically what we just discussed. If you understood what we just did in the last two examples, right? The first example, unequal sizes of 10 going into 4, one group of 4 and one group of 6. That was about it. Same thing here, 3 groups of 5, 3, and 2. And this can be extrapolated to 4 groups, 5 groups of unequal sizes, as long as they're unequal. Okay? So, if you want, I can just quickly write it as unequal sizes. So, you have m plus n by m factorial by n factorial. The total number of people that are being divided should equal. Everyone should have an allocation. Everyone should be allocated somewhere. It shouldn't be like, you have 10 people and only 7 people are being selected. Then we have to do this method right here, which we did in our previous video of combinations. But if we're gonna, if you have 10 people and we're gonna allocate all 10 of them into different groups, we're gonna make sure that no one's left out, or any group, any distinct object or people are left out. Then we can use this shortcut method. Okay. Same thing. You have m plus n plus p. Whole factorial. Sorry, I forgot to add that. And by m factorial by n factorial by p factorial. Okay, so now that we've taken a look at unequal sizes, let's have a look at equal sizes. So in equal sizes there is a catch, but let's start by solving the question. Okay, now I would recommend that you pause the video and give this a shot, see what you can do using what you have previously learned. Okay, and let's start it. So we have 4 people dividing into groups of 2 and 2. Like, think of it as 4 friends and going to play a game of tennis. So we're playing doubles tennis in this case. So let's say we have person A, B, C, and D. That's later that's for later, but let's start it now. So if we have 4 people, let's draw kind of like a tree diagram again. So I have groups of 2 like this. Now, if we work with what we were told before, which was, using the same shortcut as 4 factorial by 2 factorial by 2 factorial, that would be just half, or it would be an incomplete solution. I'll tell you why. Now, according to this, we should be having 4 factorial is 4 times 3 times 2, and 2 factorial is 2, 2 factorial is 2, so we have 4. 2 times 2 is 4, so we should have 6 total ways, right? According to this. Now there's a catch to it. Now let's break this apart. Let's make the different groups possible. So we have one group of A, B, C, D. We can have one group of AC, AC, and we can have BD, and we can have one group of AD, and we can have one group of BC. Now notice, I'm only getting 3 ways here. So again, there's a clear discrepancy. I mean, I've broken down the solution, so this has to be right? This is the right solution. So there's something wrong with this. I'll tell you what's wrong. Now, what happens is, this method, let me change the color actually. Let me put in purple. When we do it this way, this doesn't account for the repetitions. What repetitions are you asking? Well, you might have thought of 2 repetitions. You might have thought maybe, are they talking about BA repetition and DC repetition? Is that the repetition I'm talking about? No. Remember, if this is the repetition I'm talking about, then I'm going to permutations. Because that's when the order matters. Right? I'm talking about the way of selecting at the moment. Okay, it can get really, really confusing, but just have a clear thought here. Okay, so this method initially is accounting for the different order of grouping people. So in this situation, I have taken into account that I can have order of selecting of CD and AB, and then I can have BD selected first, followed by AC, or I can have BC selected first, followed by AD. And these are my three other ways. But notice, if A and B play C and D, or C and D play A and B, it's the same exact thing. It's like having a doubles tennis team saying, group one is playing group two, or group two is playing group one. It's saying the same exact thing. If you remember, it's like the same situation as like the handshake situation. If person A handshakes with person B by default is shaking hands with person A. It's the same thing. There's no difference. So there's this extra repetition. So I was supposed to have 3 ways, but I'm having 6 ways. So essentially, I'm doubling my number of ways, which is essentially saying it's 2 factorial times more. So what I'm going to do is, now the key here, there is a shortcut, but I just wanted to get this explanation across. Now, you have to make another division. So you're going to start with this. You're going to have your 4 factorial by 2 factorial by 2 factorial for sure, but you're going to have another division. You're going to divide it by the number of repetitions that's taking place. So in this case, 2, the number of groups of 2 is being repeated 2 times. Remember, that's what I'm dividing by 2. If there were 3 2s, let's say I had 6 people dividing into 3, then I would be doing 3 factorial in this situation. But I'm only doing 2 factorial because they're 2 repetitions of the 2 groups, not because they're groups of 2. I hope that that sticks in your brain. Like, don't get it mixed up. So now if I get this, so this is six ways anyways. Now divide by the 2 factorial, I'm gonna get my 3 ways. I hope that's clear. If it's not, let's take another example. And like I said, I have the example of six people into groups of 2, 2, and 2. Now, if we start off by using the same method we did in the unequal sizes, then we would have just 2 factorial by 2 factorial by 2 factorial. But we have 6 people into 2, 2, and 2. That's what we have. Now, this is being repeated 3 times, so I'm going to divide it by another 3 factorial. That's what I'm going to do. Now, let me explain it, okay? Let's break it apart again. So I have A, B, C, D, E, and F. Right? That's what I have. So I can have one group of AB, followed by one group of CD, followed by one group of EF, like that. Now, if I neglect this 3 factorial, this remaining section in red, this is accounting for the following arrangements. It's accounting for AB, EF, CD. It's accounting for this. It's also accounting for, let's say, if I come CD first, it's accounting for AB, it's accounting for EF. Let's say I have CD, EF, AB. Then I have EF, AB, CD, EF, CD, and AB. So if you can see, I initially had 1 solution, but now I have a total of 6 solutions. That means my number of ways has incorrectly increased 6 times. Hence, I have to divide by 6, or 3 factorial in this situation. Now I really hope that, the whole idea is coming into place. The pieces are joining together. Things are making a lot more intuitive sense in why I'm following this method. So now let's say we were supposed to, do this. Let's say number of ways of dividing 6 people into groups of 2, 2, and 2 let's say they're competing in some competition of a round robin competition where each play each other or something. How many different player standings can we have? Well, we can have 6 ways then, because then every order matters, right? It matters if AB comes first. It matters if CD comes first. It matters if whatever, like the position standings make sense. Oh, this team came first. This team came second. This team came third. That matters at that point. But otherwise, it doesn't matter. So this is why we have to neglect all the other situations. So what do we get now? We get, this is our final solution. Our final solution comes out to be, let me change the color, comes out to be 6 factorial by 2 factorial by 2 factorial by 2 factorial by 3 factorial. Now, if we were to solve this question by doing 6c2, 4c2, and then 2c2, we would only get this part in red. We would only get this part in red. We would still have to divide it by 3 factorial. This would still be a necessity. Now, again, if you have understood the last 2 examples of how we did the groupings, you really don't need to understand this. It's just another way of formulating, creating a formula of what we just did. So it's just, 2n whole factorial by n times n, and then what do we have? So we had something like, okay, and then dividing by 2 factorial, like this. That was the whole situation, and I think you can figure this out on your own. So this would be n by n by n by 3 factorial. Like of that situation. It's the same thing. It really doesn't matter if you can understand what we did in these 2 examples. Okay, so now that we have looked at equal sizes and unequal sizes, let's take a look at mixed sizes. Okay, so now we have the next part and the final part of this tutorial video of groups of mixed sizes. So as you can, kind of say, it's going to have equal and unequal groups, right? That's what it's going to have. So pause this video, give this a try. It's essentially using what we have done in both videos and solving it. Okay, so we're told that we have 12 people into groups of 2 of size of 3 and 3 groups of size of 2. Okay, so let's draw it out so it's visually easy to work with. Okay, so we have 12 people and we have 2 groups of 3, right? So we have 2 groups of 3, so 1, 2, and then we have 2, 2, and 2. So 3 plus 3, 6, 2 plus 2 plus 2, 6, so 6 plus 6, 12. Okay, it works out perfectly. So if we're going to solve this the shortcut way, it's going to be super simple. I'm going to have 12 factorial, and then I'm going to have 3, 3, and then the 2's, 2 factorial, 2 factorial, 2 factorial. But now I have repetitions. What's the repetitions? This is being repeated 2 times. This is being repeated 3 times. So I'm going to have, let me change the color. I'm going to make it orange. So I'm going to have 2 factorial. And I'm going to have 3 factorial. So this 2 is for the 3's, and this 3 is for the 2's. I hope that makes sense. I'm putting 2 for the 3's because the 3's are being repeated 2 times for 2 groups. Let me make this in yellow. So this is for the yellow part, and this is for the orange part, right? I hope that makes sense. And that's it. That's literally the solution. Now you can expand it if you want. You can simplify it, but I'll just stop right here because it doesn't really make much sense. Anyone can really simplify this, right? If it's a calculator section, go ahead, simplify it. If it's not, you can kind of stop right there as well. You can simplify it a little bit more. I mean, you have 6, 6, 4, 2 times 2 to 8, another 16. So you have 6 times 6 times 6, 236, 216, and 2, 16, kind of like that. Okay, let's go to the next question. Pause the video, give it a shot. Okay, so in this question we're asked, in how many ways can 8 distinct books, remember, here's the key point, it's distinct, 8 distinct books be distributed amongst 2 students in the ratio 1:3. So I hope the ratio part, right? The ratio 1:3 kind of switched on a light bulb for you guys, because the only way the ratio can take place is 2 and 6, right? That's the ratio of 1:3, and 2:6, because that's going to result in 8 total books. 8 total books. Okay, let's change the color. So now if we're gonna have 8 divided into 2 and 6, that's what we have, right? Simple case of unequal grouping, right? So we're gonna have 8 factorial by 2 factorial by 6 factorial. However, that's again not the complete solution, because we're asked to distribute them. To distribute them. We're just not grouping the books, we're distributing them as well amongst 2 students. So let's say there's student A and student B, right? So either the student can have, either the arrangement or the distribution can be 2 books and 6 books, or 6 books and 2 books. A total of 2 factorial ways. So we actually have to multiply this by 2 factorial ways. Now we can say this is going to be 2 cancels out, 56 ways. Okay, because it's being distributed, so this part, let me change the color again. I'll make this is the grouping part. This part. But this part is distributing. That's the difference. I hope that makes sense. Okay, so now we're asked, in how many ways can 8, again, distinct books be distributed amongst 3 students such that each student gets at least 2 books? Again, give it a shot, pause the video, and come back to it when you're ready. Right, so this question is a little bit more trickier than the previous question, but nonetheless, we're going to use the same approach to solve it. Okay, so we're told that there are total 8 distinct books distributed amongst 3 students, and each student is to get 2 books. So let's create the different scenarios in this situation. So if we have 8 books, right, we can have 2 students get the bare minimum of 2 books, and then we can have the last one get all the remaining books, which come out to be 4. Or we can have a situation where we have 8 books. Again, we have to maintain at least 2 books, so these two have to be at least 2. So I can reduce this from 4 to 3. So I can have 2, 3, and 3. Notice that, again, the order, whether it's 4, 2, 2, 2, 4, 2, or 3, 2, 3, doesn't matter. I don't care. I'm not caring about that, because I'm just grouping them, right? Whether it's grouped in 2, 4, 2 or 2, 2, 4, or distributed in 2, 3, 3 or 3, 2, 2, doesn't matter. It really doesn't matter at the end of the day. So now I have 2 situations. Now remember, if this is or, from my first video, remember, whenever there's or, we're gonna add the 2 different situations, the total number of ways we get in each situation. Okay, so let's solve this question. So we're gonna have 8 factorial by 2 factorial by 2 factorial by 4 factorial and another 2 factorial, because the 2's are repeated twice. Okay, similarly, we're going to add this, and we're going to have 8 factorial by 2 factorial by 3 factorial by 3 factorial by another 2 factorial. Why? Because the 3's are being repeated twice. But we're not quite yet done. We haven't finished it. And think about it for a second, why I'm saying that. Again, in this question, we're asked to distribute the books amongst 3 students. So if we're distributing them, that can be done in 3 factorial ways. Same as the previous question, same idea, same approach as the previous question. And now we have the final answer. Again, it's the same idea, right? Let's say in this situation, let's say the librarian has made a bundle of 2 books, another 2 books, and another third bundle of 4 books, and they're lying on a table like this. They're lying on a table like this, right? They're lying on a table like this. The students are, A, B, C. The different ways in which the student can come is first goes to A, B, and then C, or B, A, C, or C, A, B, or C, B, A, etc., in a total of 3 factorial or 6 ways in each solution. That's why we're multiplying it by it to both different cases. Okay, so I hope that makes sense. Let's go to the next question. Okay, so in this question, we are told that there are 14 people who are departing in 2 cars of capacity of 4 and 2 autos. Okay, so autos is kind of like these tuk-tuks that you see in India, which can hold 3 people, 1, 2, 3. They don't have a door as such, and they're fairly cheaper than a car. So they can hold 3 people, right? So let's denote the cars, for example, with C1 and C2, and autos in A1 and A2, just because it's easier to communicate. If 2 people insist on, and 2 people, and we have to find out the number of ways if 2 people insist on going in the same car. So there are 2 people who say we're gonna be going in a car only. We're not gonna go in the other means of transportation. So we have to make a kind of a forced arrangement in this case. So what we're doing is we're actually doing 2 plus 12 arrangement here. So these 2 people are already going to go in either C1 or C2, right? And they're going to go the same car, so they're going to go together, kind of like that. So remaining 12 people, we have to arrange them. So how can we arrange them? Well, 2 people can go in the remaining with the 2 forced people who are going in a car. Then we have another 4 people in the car, 3 people, and 3 people. Kind of like this. So now we have to create this arrangement. Again, we're going to follow the same procedure that we have done all along in this video. So we're going to have 12 factorial by 2 factorial by 4 factorial by 3 factorial by 3 factorial. Then we have a repetition, right, of the 3's being repeated 2 times. So I'm going to divide it by 2 factorial. Okay, so now, are we done yet? Well, not quite. Because if you remember, these people are departing. So it's kind of like distributing them in the different means of transportation that we have. So we have 2 cars and 2 autos. So that means 2 factorial for the 2 cars C1 and C2, and 2 factorial for the autos. Now we can say we have the final solution. Again, once you get the whole idea of how to break the different situations, it's just a matter of doing the same thing what we have previously done. So the tricky part in this whole permutations and these division into groups is just understanding how they're being divided, ensure that they're distinct group objects or people, and then we could work with the same idea. Okay, so final question for today is the total number of ways in which 5 balls, right? We have basketball of different colors. So again, we know that they're distinct, right? Different colors. So we know it's distinct. Distinct. It can be distributed amongst 3 people or 3 persons so that each person gets at least 1 ball. It's very similar to what we previously did. Pause the video, give it a shot, and come back. Okay, so this question is almost identical to what we previously did with the books, so I don't think it should be much of an issue, right? So we have 5 balls, at least 1 ball. So what are the situations we can have? Well, let's say we have 5 balls, so we have, let's start with the bare minimum, right? 1, 1, and 3. That's one possibility. Another possibility is having 5. Let's say we have so if I, instead of having 3, I take 2 and 2, so I have 1, 2, and 2. That's basically it. I don't think there are any more solution possibilities. So let's run through it now. So we have 5 factorial by 1 factorial by 1 factorial and 3 factorial, and I'm going to divide it by 2 factorial. Why? Because the ones are being repeated 2 times. And then I have 5 factorial by 1 factorial by 2 factorial and 2 factorial divided by 2 factorial. Why? Because the 2's are being repeated 2 times. Again, we're asked if it's being distributed. I hope I didn't mention it now. I mentioned it at the very end, but I hope you guys figured that out now, because I think this is the third or fourth question where we're now introducing distribution as well. So this was again just the grouping part, right? This was grouping. This was grouping, right? This was just grouping. Now, how can we distribute them? Well, there are 3 people, so they can be distributed 3 factorial times. 3 factorial times. Because let's say there's person A, B, and C. Well, and let's say I have created different sets of 1, 1, 3, 1, 2, 2. Let's say I've laid them on a table. Let's say person A can come first, followed by person B, followed by person C, or I can have A followed by C, followed by B. Right? There's 3 factorial, or total 6 ways. Right? So let's simplify this now. So I can start canceling them out. I can cancel this out, this, and then I get 5 times 3 times 5 times 4 times 3. This is, I think, 120. So I should be getting 60 here. Let me just double check here. 5 times 4 times 3 times 2. So 20 times, yeah, 60. Similarly here, I'm gonna have 2 times 2 times 2 is 8. And this is 6, right? So I'm gonna have 5 times 4 times 3 times 2 times 6 divided by 8. Well, 8, I'm gonna get 4 and 2, cancels it out. I'm left with 30, 90, right? This gives me total 90. So 60 plus 90 gives me a total 150 ways. It's perfect. That's our answer. So this was all for grouping. I hope you got the understanding, and I kind of segued into distribution as well, because that's an important part. Often goes neglected, and oftentimes it can result in the deduction of 1 to 2 marks at the very end. If it's a 5 or 6 mark question, especially in a paper one, which is, I believe, the non-calculator one, you can lose out 1 to 2 easy marks for overlooking this portion. And it's ideally you shouldn't miss it, because it's too easy to lose out. Like, you shouldn't be missing out on these easy opportunities. So this was all for this video, and I'll be seeing you in the next one.